Our essential question in this video, we're going to have two of them. Our first essential question is, what are the properties of central angles? Central angles. And let's go ahead and define central angle. Central angle is an angle that has its vertex at the center of the circle. If you remember your definitions class, if we have an angle measure, then the vertex is where the two sides of the angle come together. That is a vertex. And this would be our angle measure right in here. That's what we would measure in degrees. So a central angle has its vertex at the center of the circle. Let's go ahead and create a central angle on this first circle. So if you would take your straight edge, you're going to go ahead and draw a line segment from the center to a point on the circle. By the way, that's a radius. We defined that before. Let's do another one down here somewhere. It doesn't need to be exact, but just go from the center to a point on the circle. And let's take a look at what a property of a central angle is. The way you read this sentence, class, is the measure of arc AB is equal to the measure of angle ACB. Let's label these parts on our circle. Let's label this point as point A, and we'll label this point as point B, and let's label the center of the circle in this example point C. What this statement is telling you is a property of a central angle is the measure of this arc, arc AB, is equal to the measure of the angle made by this particular central angle. So here's how we would label that. If the degrees of this angle are x degrees, then the measure of this arc is also x degrees. Now remember this. To go all the way around the circle is 360 degrees. 360 degrees. So if this angle measure, this central angle, was 20 degrees, this arc AB would be 20 degrees. If the measure of this angle was 95 degrees, the measure of this arc would be 95 degrees. You measure arcs around the circle just like you measure angles in degrees, and there are 360 of them in a circle. So here's an example of this pretty simple principle. Let's go ahead and take a look at this next circle. Let's go ahead and create an angle right here. Whoops, I'm going to use a straight edge, so you should do the same thing. Let's create another radius right here. And we'll put another radius right here. And let's label some points on this circle. So let's say this is A again. And we'll call this, actually, you know what? Let's not make that A. Let's make that R. And we'll make this S. And we'll make this center point T. And let's take a look at this this statement. If the measure of angle RTS is 22 degrees, so we are saying the measure of RTS is 22 degrees, then the question is, what is the measure of arc RS? Well, we know our properties of central angles. If the central angle, which is made with an angle that has the center of the circle as its vertex, if that's 22 degrees, then the measure of arc RS is also 22 degrees, so that's easy. The measure of the arc made by a central angle is equal to the measure of the central angle itself. And now here's a weird question. What is the measure of RPS? Let's put another point on this circle. And let's label that as point P. So now we're talking about a major arc. This was a minor arc RS. RPS is the rest of the circle. Well, hey, we know that the total of a circle is 360 degrees. So we know that RPS is the whole circle minus the 22 degrees that's over here. So all we do to find this is just take 360 and subtract 22. And you're going to end up with 360 minus 22 is 338 degrees. So the measure of this arc is, and I'll put it right here, 338 degrees. Notice, class, if you add this arc, RPT, together with arc RS, you get the entire circle, Add those two numbers together, you'll get 360 degrees. So there's the basic rules of central angles. Really simple. If you know the angle measure of a central angle, you know the measure of the arc. If you know the measure of the arc, then you know the measure of the central angle. Let's compare this now to our second. Oh, you know what? Let's go ahead and define something here real quick on the top of your page. If you can define intercepted arc. It's an arc whose endpoints intersect the sides of an angle. So when you look at these examples, AB, arc AB, is the intercepted arc of angle ACB. Because look, this angle touches the circle here, touches the circle here. Kind of imagine cutting out a piece of a pizza. When you cut the piece of the pizza out, the crust is the intercepted arc. Here's another piece of pizza. We cut it out of an entire pizza. The crust is the intercepted arc, which is in this case RS. So that's what an intercepted arc is. It's an arc whose endpoints intersect the sides of an angle. All right, back to this part. How about inscribed angles? Inscribed angle is an angle that has its vertex on the circle. Now let's kind of define this. Here's the center of the circle. Here's a point in the circle. Here's a point outside the circle. And here's a point that is on the circle. So when you see these different words, when it says a vertex on the circle, it means the vertex is touching the circumference. In the circle is here, outside of the circle is here, on the circle means it is touching. Let's go ahead and create that inscribed angle. So you're going to draw two line segments. Let me make this a different color so you can see. Oops, not that one. Let's make this point a different color so you can see it right there on the circle. Okay, this is an inscribed angle because it has a vertex that's not on the center anymore like a central angle. The vertex is touching the circle. I'm going to go ahead and fill this in so you see it has to actually touch. Okay. Now let's go ahead and label some of these points. Let's label this as point A. I'm going to erase these now. That was just for you to see the difference between in, outside, and on. Let's go ahead and label that A. We'll label this B. Let's label this point on the circle where the vertex is, point D. And here's our relationship. It's different from a central angle. The measure of arc AB is twice as big as the measure of angle ADB. So if I know that angle ADB is x degrees, then I know that the measure of arc AB is 2 times x degrees. It's twice as big. So in this example, if the measure of ADB was 30 degrees, then we know that the measure of AB is 2 times 30, or 60 degrees. So that's what happens when the angle is no longer at the center. It's now on the circle. Now we don't have x and x. We have x here and 2x here. Okay, so here's an interesting example. Follow along with me. I hope you're listening to this, because if you don't listen to this, you're not going to understand this diagram. I'm going to go ahead and I'm going to draw an inscribed angle right here. Okay, so there's my inscribed angle, and let's go ahead and label, let's go ahead and label the parts, or the parts where it touches a circle. I'll label that P, and I'll label this S, and I'll label this as Q. There's where we're touching the circle. Okay, now let's say that I know that angle PSQ is 28 degrees. So I'm going to label that. This is 28 degrees. Well, you know that if the inscribed angle is 28 degrees, then arc PQ is 2 times 28 degrees. So this is going to be 2 times 28, which is equal to 56 degrees. So arc PQ must be 56 degrees. All right, and remember that arc PQ is the intercepted arc. It's the arc that is cut out of the pizza, if we call the circle a pizza, it's the arc that's cut out of the pizza with this inscribed angle PSQ. It's kind of a weird way to cut a pizza. Usually we cut it with central angles, but I guess you could cut a pizza this way. Now watch something interesting that happens. I'm going to now create another central angle. And I'm going to go to P from there, and I'm going to go to Q, the same 2 points that were the endpoints of PSQ. Now I'm going to make this a dashed line, and you should do the same thing so you can tell the difference between that line. If you're not using colors, you can tell the difference between those lines, or that inscribed angle, and the original inscribed angle. So let me get this to be dashed. Okay, there we go. So there's our dashed line. Now take a look at this, class. If this inscribed angle, let's label this as a letter R. If this inscribed angle PRQ cuts out the same piece of our circumference as the inscribed angle PSQ, then we know that angle PRQ has to also be 28 degrees. And the reason why is, think about this. We know that the inscribed angle is multiplied by 2 to find the measure of the intercepted arc, AB. Well, PRQ, this inscribed angle, has the exact same intercepted arc as PSQ. So because this is 56 degrees, we would now, instead of multiply by 2, we would divide by 2. And 56 divided by 2 tells us this angle right here, PRQ, has to also be 28 degrees. And so there's interesting property. In fact, you know what I'm going to do, just to make this a little bit clearer, let's go ahead and draw this as an arrow. Otherwise, you might get it confused with another angle in there that's a really small triangle. Let's draw an arrow there and say that's 28 degrees. Okay, so sometimes these diagrams can get very confusing, but if you can find an inscribed angle, an angle with its vertex on the circle, then you know the relationship between the angle measure and the measure of the intercepted arc. It will be the measure of the intercepted arc is twice as many degrees as the measure of the inscribed angle. So there are your properties of central angles and inscribed angles.